Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on another video of exponents and surds for mathematics grade 11. This is video 2 out of a series of 4 videos, and this comes from the Eastern Cape, November 2024 question paper, the Department of Education. And question 2, 2.1 goes simplify fully without using a calculator, and you've got your surd lined up in a common fraction type of fashion. So what you do is, with this type of questions, the first thing you do is you figure out what you can convert the number inside the square root as. Now the goal is to make sure that you change that into a product of a square and another number. Now you take a calculator and you go 32 and then divide that by 2 to see if the remainder gives us a square, and it gives us 16. So 32 now is written as 36 times 2, 36 being, no, 16 being a square, so that is equal to 16 square root of 16 times 2, 16 times 2 minus 18 can also be written as, so you do the same thing with 18. 18 divided by 2, that gives us 9, that is a square, plus minus 9 times 2, square root of 9 times 2, and the next one is 3 root 3. This one is sorted out for us. We don't need to change that to anything. All over. Same thing with 108. Take out a calculator and you go 108. That's if you don't know your squares and square roots and all of that. So that's divided by 2 and it gives us 54. 54 is not a perfect square, so let's try dividing that by 3 and see what we get. So let's go back, divide that by 3. There we go. It gives us 36, and that is a square, so that will be 36 multiplied by 3, and that's how you convert that. So it will be the square root of 36 times 3 plus 8 is simply 4 times 2. 4 is a square. Now what you do is you now simplify. The square root of 16 is 4, so that gives us 4 root 2 minus 3 root 2, that is the square root of 9, plus 3 root 3, plus 3 root 3, all over the square root of 36 is 6, so that is 6 root 3 plus 2 root 2 plus 2 root 2. Now you add like terms. This is a goat. 4 goats minus 3 goats, that is 1 goat, so that gives us just 1 goat, which is the square root of 2. So that's 1 square root of 2 plus 3 root 3 all over, and that gives us 6 root 3, 6 root 3 plus 2 root 2. Alright, now what you do is rearrange this. Let's rearrange this. Okay, we can rearrange this. We may start with 2 root 2, or you can rearrange the numerator. It's up to you. You can do that with numbers that are added together. You can rearrange them anyhow. So that is square root of 2 divide plus 3 root 3 all over 2 root 2, 2 root 2 plus 6 root 3. I just wanted to see exactly what's happening here so you can see for yourself. And now we factorize the denominator, and you will see we'll end up with a common factor. We'll take out a common factor at the bottom. The common factor is 2, and that leaves us with root 2 plus 3 root 3. Root 2 plus 3 root 3 and now notice that root 2 plus 3 root 3 is exactly the same thing as this one, so we cancel out, and that leaves us with 1 over, so this goes once, so that leaves us with 1 over 2, and that is how you simplify that. That leaves us with 1 over 2, and that's the answer there. Next question, let's go back to the main question. Next question is 2.2 solve for x. 2.2.1 goes 2 to the power of minus 5 over 2 equals to 64. Now this type of questions are very easy to solve. And what you do is step number 1, treat it as you would any other equation, linear equation. So step number 1 is to divide throughout by 2. So you go, that is x to the power of minus 5 over 2 equals to, now 64 divided by 2, that gives us 32. So therefore you got x to the power of minus 5 over 2 equals to 32. And 32 can be written as 2 to the power of 5. You're not sure, you go, take your calculator and go 32 equals to shift fact, and it will change your number into exponential form, which is 2 to the power of 5. There you go. So that is equals to, therefore, x to the power of minus 5 over 2 equals to 2 to the power of 5. Now next step is you raise this to the power of the reciprocal, negative reciprocal in this case, because the goal is to end up with x to the power of 1. So we raise this all to the power of the negative reciprocal, and that is negative 2 to the power of 5. What you do to the left hand side, you must also do to the right hand side. That is the rule of equation, so we do the same. Raise it to the power of negative 2 over 5 to the right hand side. Now, when you raise a power to another power according to exponents, is the laws of exponent is that now you multiply the exponents. Same thing over here on the right hand side, sorry about that. Okay, you also raise this one, that becomes 2 to the power of 5 times negative 2 over 5. Now these ones cancel out, so these ones cancel out. Okay, let's change this to red. They cancel out, 2's cancel out, and the negatives cancel out, and they multiply together and give you 1. These ones also cancel out, and you're left with 2 to the negative 2. So this is x to the power of 1 equals to 2 to the power of negative 2. 2 to the power of negative 2, which is equal to x is 1 over 2 to the power of 2, and 2, which is equals to, therefore x equals to 1 over 4, and that is the answer. You can check that if you want to, don't have to, but let me show you how you will check if you were to check that. So we're checking that x equals to 1 over 4. Okay, on the left hand side that will be equals to, on the left hand side that will be equals to 2, and wherever there is x we'll put 1 over 4, all to the power of negative 5 over 2. Negative 5 over 2. You can take a calculator and quickly calculate this. Let's do that. So that will be 2, open bracket. Okay, and that was what? Common fraction button, 1 over 4. Okay, I'm just taking a shortcut here. And that is all to the power of negative 5 over 2. So that's x to the power of what? 5y minus common fraction button. to negative 2 over 5. All right, let's just double check everything. That's negative 5 over 2, not 2 over 5. So let's change that. Negative 5 over 2. And then you go equals to, all right, let's go equals to, and that will give us 64, which is equals to the right hand side. And so therefore, left hand side equals to the right hand side, meaning that therefore x equals to 1 over 4 is the solution. That's how you check. This is the solution. Next question. Let's go back to the main question. Next question goes 2.2.2, 3 to the power of 5, 3 times 5 to the power of x minus 5 to the power of x minus 1 equals to 14. Now what you do with these questions, if you find a question like this, step number 1, break everything up into individual exponents so that you can see exactly what's up. So therefore 3 times 5 to the power of x minus 5 to the power of x, that's what we get, times 5 to the power of negative 1. That's what you do when you break that up. All right, when you multiply powers of the same base, you add the exponents, and to reverse that, you just simply break it up like that. Now notice that we've got a common factor, and here is the common factor. Let me show you what the common factor is. The common factor is 5 to the power of x. That is 5 to the power of x. Keep that in mind. All right. Okay, so therefore 3 times 5 to the power of x minus 5 to the power of x times 1 over 5 equals to 14. All right. Now let k equals to 5 to the power of x, just to make your life easier. All right. Now let's replace everything by k. You don't have to do this. It just makes life so much easier, especially for those people that struggle to see or to work with powers like this when they are raw. So now you have this fractional equation. Now you've got an LCD of 5, the lowest common denominator. Now what you do is you multiply throughout by that common denominator. All right, so that will be 5 times 3 times k minus 5 times k over 5 equals to 14 times 5. Multiply every term by that. Now this leaves us with 15k minus k, because the 5's cancel out, and that is equals to 14 times 5. Always use a calculator in an exam to avoid making those silly mistakes, and that gives us 70. All right, so that's 15k minus k, that is 14k, equals to 70. And now we can go ahead and divide both sides by 14, and that gives us 70 divided by 14. That is 70 divided by 14. That gives us 5. Okay, therefore k equals to 5. Now we're not solving for k, we're solving for x, so we revert back to 5 to the power of x. Therefore 5 to the power of x equals to 5. 5 can also be written as 5 to the power of 1. And now we've got powers of the same base equal. Therefore, we simply equate the exponents. And there, x equals to 1. Now to check, always check. To check that x equals to 1, we go to the left-hand side and substitute 1 wherever there is x. So go back to the original equation. The left hand side is 3 times 5 to the power of x. So that will be 3 times 5 to the power of 1 minus 5 to the power of 1 minus 1. So that is 5 to the power of 1 minus 1. And that gives us 3 times 5 minus 5 to the power of 0. 1 minus 1 is 0. And we know that anything to the power of 0 is 1. 3 times 5 is 15 minus 1. And that gives us 14, which is equals to the right hand side. Which is equals to the right hand side. Therefore, x equals to 1 is the solution. That is the solution, and that's how you check. Next question, and that is the final question in this video. Calculate a possible value for a squared plus b squared if it is given that a and b are rational numbers, such that the square root of a plus the square root of b is equals to the square root of 9 plus the square root of 56. Now what you do is you square both sides. That is the best thing to do. Alright, so this is what we have. The scenario that we have. We're supposed to calculate a squared plus b squared, but before we do that, we need to figure out what a is and what b is. So using this, we square both sides. We can square both sides. Square root of a plus square root of b, square this, and also square the right hand side. That will be, alright, we square both sides. Now the side on the right hand side simply becomes 9 plus square root of 15, 6. That's what you do. You just remove the square root sign. Now on the left hand side, we've got, you can use the square of a binomial, or you can use 4 to multiply this out. So that gives us, I prefer the square of a binomial. That is the square of the first term plus 2 times the product of the factors of the terms plus the square of the last term with its sign. That's what I prefer. Now on the left hand side, we've got a, the square root of a squared is a plus 2 times the square root of a times b plus b equals to 9 plus. Now the square root of 56, you can without using a calculator if you had to, okay, but you can do this. You go 56 divided by 2 to find what the square is. Doesn't give us a square. Divide by 3, doesn't give us a square. Divide by 4, it gives us 14. 4 is a square, so that will be square root of 4 times 14. Square root of 4 times 14, and that can be written as 2 root 14. So that's what that becomes, 2 square root of 14. Now we have on the left hand side, now we rearrange the left hand side to look similar to the right hand side. So that will give us a plus b, all right, plus 2 root ab. Square root of ab equals to 9 plus 2 square root of 14. Now notice something. I wanted to see something here. 2 square root of ab matches with this one. 2 square root of, let me show you. This one matches with this one. And the 9 matches with the a plus b. 9 is just a number. A plus b is also just a number. This is 2 root ab, and that is 2 root 14. So therefore, that means Therefore, we can simply equate a plus b to the number 9, and that will be our equation 1. Remember, we're solving for two things at the same time, therefore we use simultaneous equations. And the other one, the second one, will be equating 2 root ab to 2 root 14. Therefore, also 2 root ab is equals to 2 root 14, and that we make equation 2. All right. From 2, now you can solve this anyhow. There are many ways to kill a cat. All right, we go 2 root ab equals to 2 root 14, meaning that therefore if you divide both sides by 2, you're left with 2 root 8b is equals to root 14, meaning that therefore we can simply conclude ab is equals to 14. All right, this is from, all right, let's make this, okay, therefore it means that a can be written as 14 over b, if that's what you prefer, or you can go back and make a equals to 9 minus b over there. It's up to you which one you prefer to use. It's up to you. There are many ways to kill a cat. Like I'm saying, use whatever method works to you for you to solve the simultaneous equation. Now substitute 3 back into 2, into 1, because that was from 2. Substitute equation 3 into 1, equation 1. Therefore what we have is this. Wherever there is a, we put 14 over b. Therefore a plus 14 over b equals to 9 sorry, the a is this one, sorry about that, 14 over b, where there's a, we put 14 over b plus b equals to 9. Now we multiply throughout by b, so that will be 14 plus b squared equals to 9 times b. Now therefore b squared minus 9b plus 14, write this in standard format, equals to 0. Now let's solve this by factorizing first. Okay, that will be b and b. Now we look for factors of 14. That will give us 9. 14 times 1, then we've got 7 times 2. This is the 1, 7 and 2. 7 and 2 will give us 9, minus and minus. Alright, therefore b minus 2, never skip this one, equals to 0, or b minus 7 equals to 0. Never skip this step. I've seen many people make some mistakes and end up with the wrong answer because of a simple minor mistake. B equals to 2 or b equals to 7. Now we take these b's and substitute them back into equation 3 to figure out what the a is. Now substitute the b's into 3. Equation 3. I'm gonna make 2 sections so we can go about doing this side by side. Alright, let's make it thinner. So on the left hand side, we're going to substitute for b equals to 2. For b equals to 2. And on the right hand side, we're going to substitute for b equals to 7. Alright, on the left hand side, when b equals to 2, we go back to equation 3. A equals to 14 over 2. And that is equal to 7. Therefore, a equals to 7. And on the other side, when b equals to 7, Therefore, A equals to 14 over 7, and that gives us A equals to 2. So when B, so therefore you have this scenario, therefore, all right, A equals 2 and B equals 2. So here we've got our A is 7 and B is 2. Or this combination, A equals 2 and B equals 2. Either A equals to or A equals to 2 and B equals to 7. Now let's check. If you were to check, notice that all you need to do is to find A times B, that gives us 14. Now for this one, 7 times 2 will give us 14. Right? And 7 plus 2 will also give us 9. It checks out. Same story over here. 2 times 7 will give us 14. And 2 plus 7 will give us 9. So either way, it checks out. Therefore, this is the solution. Therefore, this is the solution. And that was the last of the questions. Thank you so much for watching. I'll see you in video number 3, which is the third in this series of 4 videos. Bye-bye.